LangGraph employs a stateful message passing architecture to orchestrate decision-making workflows, where the messages state serves as the central data structure for tracking conversation history and tool interactions. This pattern enables dynamic routing between computational nodes based on real-time evaluation of message content and tool responses. We're about to examine how the system initializes its core components: a chat model configured for deterministic output and a decision node that evaluates whether to invoke retrieval tools or respond directly. The setup demonstrates tool binding to the language model and stateful message handling, foundational patterns for building adaptive retrieval agents.
From LangGraph, graph import MessagesState. From LangChain, chat models import init chat model. Response model equals init, chat model GPT, temperature equals 0. Def generate query or response state, MessagesState. Call the model to generate a response based on the current state. Given the question, it will decide to retrieve using the retriever tool or simply respond to the user. Response equals response model, bind tools retriever tool, invoke state messages, return messages, response.
This function implements a decision-making node in a retrieval-augmented generation workflow. It uses a language model bound to a retrieval tool to determine whether to fetch external information or respond directly to the user. The key design choice here is delegating the retrieval decision to the LLM itself, rather than using static rules or separate classifiers. The approach creates a flexible system where the model can dynamically choose between direct response and information retrieval based on the conversation context. This is particularly valuable when the knowledge cutoff of the base model might be insufficient, or when dealing with domain-specific queries that benefit from external data sources. The trade-off is increased latency when retrieval is triggered, and the need for careful tool design to avoid unnecessary API calls. By binding the retriever tool directly to the model using bind tools, the system maintains a clean separation between decision logic and tool execution. The function preserves the message state structure expected by LangGraph, ensuring compatibility with the broader workflow while keeping the decision logic encapsulated in the single node. This pattern works well for knowledge-intensive applications where the relevance of external data isn't always predictable. Let's break it down.
From LangGraph, graph import MessagesState.
Imports the MessagesState class from the LangGraph graph module, which provides state management functionality for message-based workflows in LangGraph. This class is specifically designed to handle and track the state of messages as they flow through a graph-based processing pipeline.
From LangChain, chat models import init chat model.
Imports the init chat model function from LangChain's chat models module, which provides functionality to initialize and configure chat-based language models.
Response model equals init, chat model GPT, temperature equals 0.
Initializes a chat model using the GPT-4, one model with a temperature setting of 0, which means the model will generate deterministic responses with no randomness. The resulting model instance is assigned to the variable response model.
Def generate query or response state, MessagesState. Call the model to generate a response based on the current state. Given
defines a function named generate query or respond that takes a single parameter, state of type MessagesState. The function's docstring indicates it will call a model to generate a response based on the current state, though the implementation details aren't visible in this segment. The function signature suggests it's designed to either generate a query or produce a response, likely based on the provided state object containing message history or context.
The question, It will decide to retrieve using the retriever tool, or simply respond to the user.
This line describes a conditional decision-making process, where the system evaluates the question and determines whether to use the retriever tool to fetch relevant information or to respond directly to the user based on the question's content. The decision hinges on whether the question requires external data retrieval or can be answered with existing knowledge.
Bind tool's retriever tool. Invoke state messages.
Binds the retriever tool to the current object and immediately invokes it with the messages from the state dictionary. The method chain first configures the tool binding, then executes the invocation with the provided message data.
Return messages. Response.
Returns a dictionary with a single key, messages, containing a list with the response object as its only element. This formats the output in a standardized structure where the response is wrapped in a messages array, which is a common pattern for API responses or message-based systems. This implementation demonstrates LangGraph's stateful message passing architecture in action, where the messages state serves as the backbone for tracking conversation history and tool interactions. The core pattern here is dynamic decision-making through tool binding. The language model itself determines whether to retrieve external information or respond directly, rather than relying on static routing rules. The deterministic chat model configuration with temperature equals 0 ensures consistent behavior, which is crucial for predictable workflows. By binding the retriever tool directly to the model using bind tools, the system maintains clean separation between decision logic and execution while preserving the message state structure required by LangGraph. This design choice creates flexibility for knowledge-intensive applications where external data relevance isn't always predictable, though it introduces the trade-off of potential latency when retrieval is triggered. The function's return format wraps responses in the expected message structure, ensuring compatibility with the broader workflow while keeping the decision logic neatly encapsulated. This pattern exemplifies how LangGraph enables adaptive retrieval agents through stateful message handling and dynamic tool invocation.
The LLM binds tools to messages, weaving silence into answers that refuse to speak.